Hi, it's Adam. We're still going to be working on Oppgave 8a, but this time I'm going to be showing the shell method. There we go. So the shell method on doing this. We're trying to find the volume, obviously, of f of x is like x squared, or is equal to, rather. And I'm just going to quickly redraw this function. Remember, it's still going to be the exact same shape, except for we're thinking of this in different terms. So it's between x is equal to 1 and x is equal to 3. So before, we took these disks that went from 1 to 3 with a radius of this height and a thickness of the change in x. But with the shell method, you are going to take it along the y value. And the reason for that is you're going to make a bunch of small cylinders or shells, except for this is hollow in there. So if you think that you take a slice here and then you take that slice all the way around, you end up with something like this. Completely hollow, very thin, but it's a cylinder. So before, with the disk method, you were going for the area of the top of this disk. But this time, we're going for the surface area of the outside of these little shells. So again, if I had this, it would be this outside area all the way around. So the easiest way to do that is obviously to take, you're going to think of a circle. You need the circumference of that circle multiplied by the height of the eventual cylinder, which would give you this. So basically, if you cut this in a line, you would have a rectangle, and then you would be finding the surface area to that rectangle if it was laid out flat rather than in a circle. When you have this area, you need to multiply that by the thickness of this cylinder, which would then give you the individual volumes of each of these cylinders. And you're going to take the sum of all of those, as the cylinder starts from an infinitely small and becomes larger out to the edges, you need the sum of all of those. So, what's the circumference of a circle? That is 2 pi r. The thickness would be the thickness of this paper. That would be the change in y. Remember, that's infinitely small, so we can take that as dy. And then the height, if you look here, what is the height? The height of each of these is the I'll just put h. Take radius and height. Those are the two things we're trying to find. The height is going to be from 3, because that would be the max amount. And then you need to subtract the x value of the function. Because if we took just the total height, we would get all this area in between here, which isn't something that we're after. Only going for this, so therefore it's 3, the max amount, minus, you're subtracting everything on that side of the curve. So you need to find the x values of that. So this, f of x is equal to x squared is the same as y is equal to x squared, which means that x is equal to the square root of y. So when you're subtracting that x value from the function, it is then 3 minus the square root of y. That would be your height. The radius is going to be just this, it would be the height of the function itself, which is just going to be x squared. Because that's the x function. It will give you how high up this is. So that means, if we put it all together, volume is 2 pi times r which is 3 minus the square root of y, times the height. Oh, I'm sorry, that is the height, but it doesn't matter. Times, that would be x squared. But remember, if we are going to have an x in here, then we're going to have a blending of y's and x's. So we can say that x squared is also equal to the function of x, which is also equal to y. So we're going to multiply that by y and dy. And now we have everything expressed in y. I'll multiply that in. We get volume is equal to 2 pi 3y minus y square root of y dy. We can simplify this further. The volume is equal to 2 pi 3y minus y 3 over 2 dy. So this is what we're going to end up working with. Remember, now we're going to integrate. We want all of these, the sum of all of those. So we can take that the volume is then equal to 2 pi times the integral of 3y minus y 3 over 2 dy. But we also need to find out where we're integrating to and from. So before it was from 1 and 3, because our disks were moving from this side to that side. But now our disks are moving from the bottom up. So you might have been tempted to say that, well, from this point to that point, that would be y is equal to 1 and y is equal to 9. But what you need to do is you need to take y from 0 to 9. And the reason is now, with x we were going from here, but from y we are going completely from the x-axis, because this is going to be solid. I got my kids running around, so I apologize. So you have it from 0 to 9. Now if we integrate that, we get that v is equal to 2 pi times 3y integrated is 3 over 2y squared minus, and then we take y plus 1 on that is going to be 5 over 2. Divide by 5 over 2, you get 2 over 5. And then it's going to be between 9 and 0. So that means that the volume is going to, I probably should have taken a longer line on this, but oh well. The volume is going to be equal to 2 pi, and that's going to be multiplied. You can see that this is going to be, what is that, 81 times 3 over 2, 243 divided by 2. And that's going to be that section minus, and then, yeah, that is, luckily I have this written down, 486 divided by 5. So, yeah, that's just me plugging the 9 into the y's. This is just going to be 0 on both of that, so it's not going to affect anything. So that means that the volume is then equal to 2 pi, and then if you put those two together, you end up with 243 divided by 5 pi. Yeah, well. Excuse me, divided by 10. Divided by 10. But after you multiply that 2 in, it then becomes volume equals 243 divided by 5. There we go. But somebody's probably already noticed that this is 243 divided by 5, while that is 242 divided by 5. So those two answers are not exactly the same. And the reason for that is this right here. When we take from y is 0 all the way up to y is 9, you get this whole disk. But we're not taking that last little section, so we actually have a little, I guess it's kind of like a little spike. That creates a spike because that's taken around the x-axis. So we need to find the volume of that spike so that we can just kind of cut that part off. That spike, I'll just, it's the same function, just looks like this. But now we're going from 0 to 1. this is easier to calculate if you're going to use, obviously, disk method, so I'm just going to quickly run through the disk method on it. That gives you, we can just look up here. That's going to be pi r squared times the height. R is then equal to x squared. The height is equal to dx. Okay? So this then equals pi r cubed, x cubed dx. Now, when we integrate this, we are going to get that it is pi times the integral from 0 to 1, x to the 4th dx, and then that is equal to the volume of pi bracket x is going to go to the 5th, divided by 5, you get 1/5, between 0 and 1. 0 doesn't make any difference because that's going to be 0, so 1 is equal to, if you multiply that in, 1 to the 5th is 1 times the 5th. That means that the volume of that little tiny spike right here is then equal to pi over 5, or 1/5 pi. So if then you take this volume here, which is 243 over 5, I'll just take 243 pi, minus pi over 5, 243 minus 1 is then 242 pi over 5. And then we have a matching answer to that. And that was, obviously you would only use a disk method with this, but in case somebody had asked, well, how would you do that with the shell method, or if we get that on the exam or whatever else, that is then how you would do it with the shell method.